In this lesson, we'll study how to add or subtract rational expressions. Adding or subtracting rational expressions works nearly the same way as adding or subtracting just fractions. Remember, when we add or subtract fractions, we need to have the same denominator. So here, for rational expressions, we will also look for common denominator. At first, let's see how do we add and subtract expressions that will already have the same denominator. Well, we add or subtract the numerators and keep the denominator the same. Now, after we finish this addition or subtraction, we'll obtain an expression that could possibly be simplified. So, in order to do that, we need to factor completely the numerator and denominator and then reduce if possible. Let's see some examples. In the first example, we have exactly the same denominator, 2x, so we're going to keep it. Let's draw a little bit longer division bar, 2x, and we just need to collect the existing numerators. So the first one is x plus 3, then it's plus 2x minus 1. And here we need to be careful because this minus refers to entire fraction, meaning that the minus refers to the whole numerator. Okay, so we can write negative bracket x plus 2. And in the second step, we're going to open this bracket by reversing signs. This sign will cause reversing the plus by x into minus and plus by 2 into minus. So let's combine all the x's. We'll have 1x from here, 2x is there, so it's altogether 3x. Then it's 3 minus 1, which is plus 2. And then release the bracket, we'll get negative x and negative 2. And we're going to combine those like terms again. So 3x minus x is 2x, 2 minus 2 disappears, it's just 0. And then divide by 2x. Oh, that looks really nice, because we can actually divide 2x by 2x. It becomes 1. So this whole big expression is equal to 1. Let's see the next example. Again, we have the same denominator, so we keep it, x minus 3. And then rewrite the numerators as they are, so it's x squared. Again, this minus refers to entire numerator, so make sure that you enclose the numerator in a bracket. Negative x plus 6. Now let's release the bracket and we end up with x squared minus x, and remember to switch the sign, minus 6, over x minus 3. Okay, so we actually subtracted the expressions already. But let's see if the resulting expression can be simplified. This can be done only if the numerator can be factored. So let's see if this can be factored. Well, the product is negative 6, so we're looking for two numbers of different signs such that they will differ by 1. So let's prepare two brackets. Here's x and there's x. Now the product 6 difference 1, it must be 3 and 2. 2 times 3 is 6, and since after adding these two numbers we should end up with negative 1, then the negative will be by 3 and positive by 2. The larger number takes the middle sign. Okay, let's copy the denominator, and yes, we can actually reduce the factor x minus 3. Let's do it. So the final answer is just x plus 2. Okay, so that wasn't too difficult, wasn't it? Now let's try to extend our skills of adding or subtracting rational expressions to the ones that have different denominators. How can we do that? Well, we need to rewrite the given expressions in equivalent form that will have the same denominator. So first, let's learn how to find the least common denominator. LCD, least common denominator. Sometimes it's called least common multiple, LCM. That means exactly the same. So to find least common denominator, we need to factor completely every denominator that we work with. And then we need to take every different factor to the greatest number of times that it appears in any one factorization and multiply them. So let's see how it works. To find the least common multiple for these two expressions, what we do is find the LCM for the numbers. So work with numerical coefficients first. Quite often those numbers are easy enough to guess least common denominator. However, these ones are kind of high. So let's recall the method how to find LCD for two numbers. Well, we can list those numbers, 24 and 18. It could be even more than 2, but in this case just 2. And then we can divide by a common factor, any common factor that comes to your mind. It doesn't have to be prime. So for example here, both numbers are divisible by 6. 24 divided by 6 is 4, 18 divided by 6 is 3. And then between these two numbers there's no common factor except for 1, but 1 doesn't count. We are searching for common factors that are higher than 1. So that's actually the end of our search. The least common denominator comes from this first column and last row. So you can see here a letter L, and if we multiply all the numbers that are in this letter L, we end up with least common denominator, and in this case it's 12 times 6, which is 72. Okay, so we have the least common multiple for these two numbers. It is 72. As a matter of letters, we're choosing the common letter, which is A, to the highest exponent of occurrence in each expression. So a square needs to be taken. Why? Well, because we are searching for an expression that will contain 18a squared as a factor, as well as 24a as a factor. So as you see, both of these expressions will divide evenly into 72a squared. Well, let's put an arrow here rather than an equation, because 72a squared is the least common denominator of these two expressions. It's not equal to those expressions. Okay, let's look at the next example. This time we have three expressions to find the least common multiple of. Again, let's find the LCM for the numerical coefficients. So 6, 4, and 5. Well, if I want to use the L method, I can list my 6, 4, and 5, and the method works like this. I am looking for common factor for all three of them, but in this case there isn't any. So my second question is, do I have a common factor for at least two of those numbers? And yes, I have. 6 and 4 is divisible by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. 5 is not divisible by 2, so the rule is copy it down. Don't do anything. Okay, in this row, I don't have any pair of numbers that would have common divisor. So that's the end of my search. The least common denominator is the product of all these numbers in the letter L. So it will be 6 times 10, which is 60. Okay, so LCM will have to contain 60. Now, as a matter of letters or expressions, what we need to do is make sure that everything is factored completely. So there's no problem here and no problem in the last expression. It is factored, but the second expression is not quite factored. Okay, let's rewrite this bracket as x times x minus 1. So now we have all expressions in a factored form. And we apply the second step. We need to accommodate for all factors in our LCM. So the first factor is x. It appears once here, once there, and not here. Therefore, I need to take just one x. Then y. Y appears once here, no y here, and y to the second degree. So I need to take the highest degree of occurrence. That means y squared. Finally, another factor that is different than previous factors is x minus 1, the bracket. The bracket appears once here, but twice over there. There's exponent 2. So take the highest power of occurrence of particular factor. So it's 2. That's our LCD. Well, let's look at the next example. The best idea would be to rewrite all the expressions that are not factored yet in a factored form. So let's rewrite everything in a factored form. X minus 5 then this is a difference of squares. It factors into x minus 5 and x plus 5. And here we can factor the 2 as a common factor out of the bracket and x plus 5 in a bracket. So now LCD for all three of those expressions will be numerical coefficient that I need to take is 2, and we have two types of brackets. The x minus 5 that appears once here, once there, and not at all here. So we need to take x minus 5 once. In the second type of bracket, x plus 5, again it appears once here and once there. Yes, we need to take x plus 5 to include in LCD. So that's our LCD for all three expressions. And the last example, again, let's factor each expression first. Look at the first one. What do you see here? Do you observe any pattern? Yes, that's n plus 3 square. It's a perfect square of n plus 3. And the second expression, take the common factor 5 out, so it's n plus 3 here. Okay, what's LCD then? LCD of those two expressions is, we need to take 5, we need to take n plus 3, but how many times? The greatest number of times that it appears in any factorization. So it appears twice here, so we need to take n plus 3 square. Okay, I hope you've got the idea how to find LCDs. And if you need more practice, please take some questions from the textbook. Before we start adding or subtracting rational expressions with different denominators, let's practice one more preparation exercise. How do we extend a fraction to the new denominator? Let's say we have this expression, but we would like to write it with the denominator x squared minus 1, because maybe that will be the common denominator. So how do we change this fraction to a fraction with such denominator? Well, the first thing that I would suggest is to factor the second denominator. This is difference of squares, so it factors into two brackets, x plus 1 and x minus 1. Now, if we want to make sure that these two expressions are equal, that my x over x plus 1 is equal to something over x plus 1 times x minus 1, then I need to look at what's happened to the old denominator. Well, we still have x plus 1, it's the same, but the new factor that appears here is x minus 1. So if we just rewrite the x, that wouldn't be enough, because we multiply denominator by x minus 1. To make sure that the overall fraction is not changed, we need to multiply the numerator by the same x minus 1. So you see, x minus 1 over x minus 1 is actually the same as 1. So we multiply the blue fraction by something that is equal to 1. Therefore, we didn't change the value of the overall fraction. So let's look again at this process. What have we done? We factored the denominator, and then we decide which factors are new that turn out to be x minus 1. And finally, we need to multiply the numerator by exactly the same factor. So the new fraction will not change the value of the original one. Therefore, the final answer could be written as x times x minus 1, or you could even multiply and write x squared minus x. So this expression is equivalent to the original expression. Okay, let's look at the second example. This time the denominators looks very similar. They are not exactly the same, but they are related. How are they related? Well, you can observe that this new denominator is actually the opposite to the old denominator. If we take negative 2 minus x, we actually have plus x and minus 2. Since this is an opposite to the old denominator, what's happened is we change the sign in the denominator. Therefore, we have to change the sign in the numerator, because these two negatives will actually annihilate each other, and you end up with exactly the same fraction. So changing the sign in the top and the bottom sometimes it's very useful skill to get the new denominator. There's no need to multiply these two denominators because then you go into too complicated expression. So take advantage of opposite expressions if possible. Another example, we need to bring a minus 6 into such a denominator. So the first step, as usual, would be to factor and see what this denominator is composed of. Okay, let's prepare two brackets. Here's a and there's a. Now the product is 30 and difference 1. So 6 times 5 gives us product 30 and they differ by 1. The larger number takes the middle sign. So larger number is 6 and it will take the negative sign. Therefore the other number is plus 5. Okay, let's copy the 3a. If you look at this part of the expression, that's exactly the same what we had before. But then we wanted to multiply denominator by extra bracket a plus 5. So in order to keep the overall fraction exactly the same, we have to multiply the numerator by the same a plus 5. Because a plus 5 over a plus 5 really cancel each other. Well, so now we know what to write in the numerator of the final expression. This could be written in a factored form as it is, or if you multiply, it could look like 3a squared plus 15a. And last example, what do we have here? 3 minus 2x, and if I take the common factor from this denominator, which is 4, out of the bracket, what's left is 2x minus 3. Okay, but original denominator was 3 minus 2x. So how can I make this bracket exactly the same as 3 minus 2x? Well, by pulling the minus outside. So instead of 4, factor negative 4. And then we have 3 minus 2x. Okay, therefore we have negative 4 and then 3 minus 2x, which is the same as it was originally. If I rewrite my x minus 3, this part of the fraction is the same as it was. Therefore, the only change that happens is multiplying by negative 4. If we decided to multiply by negative 4 the denominator, we have to do the same to the numerator. And our final answer is negative 4x plus 12. So this expression is equivalent to the original one. Okay, now we are ready to perform addition or subtraction on any rational expressions. For example, here we have two different denominators. So let's try to rewrite those two fractions in equivalent form with the same denominator. So that will be the first fraction, then minus, and the second fraction. First, let's copy the fractions as they were. So x plus 3 over x squared, and here x plus 5 over 2x. Now, since I want to have the same denominator, and I'm sure you know the LCD for these two denominators already, what is it? Well, we need to take the 2 and we need to take the x to the highest exponent. So our lowest common denominator will be 2x squared. What do we have to do with the x squared to get 2x squared? Oh, we need to multiply it by 2. But if we multiply the bottom by 2, we have to multiply the top by 2 as well. Now look at the second fraction. What do we have to do with 2x to get 2x squared? Yes, we need to multiply by x. So we need to multiply by x the numerator as well, because this way we don't change the value of the fractions. Great, so now we can write everything under common division bar with the common denominator 2x squared. And then just copy whatever you see in numerators. So 2 times the bracket minus x times the bracket. Let's release those brackets and multiply by 2 here. So it's 2x plus 6, and then it's minus. So please watch this minus. In order to protect yourself from possible mistakes, make sure that after such minus you put a bracket and then you multiply x times x is x squared and plus 5x. You release this bracket in the next step. So now it's time to release the bracket. We have 2x plus 6 minus x squared and minus 5x, because this minus changes the plus into minus. 5x over 2x squared. Let's carry on. Start our numerator with the highest exponent, so it will be negative x squared. Now we need to combine 2x and negative 5x, so it's negative 3x, and copy plus 6. Everything over 2x squared. And it looks like we can't really cancel anything because the numerator is not factorable. So that will be our final answer. Okay, let's look at the next example. In this example, we see very similar denominators. The only thing that is needed to do here is to take opposite to this denominator. So if I place a minus in front of this denominator and place a minus in front of numerator, it's like I haven't done anything. However, the denominators will be exactly the same because this is the same as r squared minus 4, which is exactly the same as the first one. So that's even easier than the previous case. We can write r squared minus 4 as a common denominator, and then the numerator is r plus 2. However, this 4 will become negative 4. Now let's combine like terms. We'll have r minus 2 over r squared minus 4. But now we can predict that if we factor r squared minus 4, which is difference of squares, then one of those brackets, one of those factors, could be reduced. So we have r minus 2 and r plus 2. And that's great. We can reduce r minus 2. So what's left? You see there is nothing in the numerator, but you still need to remember that nothing for multiplication really means 1. We have to keep this 1 to keep the numerator alive. And the denominators are plus 2. So here's the final answer for this question. Thumbs up. I hope you will practice more on your own. So I wonder if you can pause this video and try those examples on your own, and then come back to the video and compare your answers. Okay, let's do example C. To rewrite those two expressions with common denominator, we need to see what is this LCD first. In order to do that, we need to factor every denominator. So for example, this denominator consists of x minus 2 and x plus 2 because it's a difference of squares. Now, if we observe the numerator in this particular example, if we factor the 2 out, we'll end up with x from here and 2 from there. So if you notice this, you could actually reduce the x plus 2. So reducing this fraction will cause that the remaining fraction has exactly the same denominator, so the overall question becomes a lot easier. So what we can do here is keep this common denominator x minus 2 and then copy the first numerator x plus the second numerator just 2. Well, you see, this is already final answer. Great. We've done this a lot easier. However, if you didn't notice that this numerator factors and then you can reduce, you can still do this question the regular way. That means here will be a second solution by writing the least common denominator, which is x minus 2 and x plus 2, and then extending the first fraction by multiplying the top and the bottom by the missing bracket, by the x plus 2 bracket. So we'll end up with x times x plus 2 from the first fraction, and then it's plus the old numerator 4 plus 2x as it was, because we didn't change the denominator of the second fraction. And then release the bracket and collect like terms. So we'll have x squared plus 2x plus 4 plus 2x over x minus 2 and x plus 2. Now, if we add like terms, we have x squared plus 4x plus 4 over x minus 2 and x plus 2. And finally, we should notice that the numerator is actually perfect square. It's a perfect square of x plus 2 squared. And denominator, copy it. And now you can see that we have exactly the same factor, x plus 2. that can be reduced with one of the x plus 2 bracket here. Therefore, the final answer is as before, x plus 2 over x minus 2. See, the second solution gives us the same answer. Obviously, it must be the same answer, but it is a lot more work. So if you're attentive and if you could reduce this fraction first, well, that will be a lot faster. Let's see the next example. Here, we definitely can't reduce anything, so we have to use lowest common denominator. And in preparation for finding lowest common denominator, let's factor this denominator. We'll have c here and c there. The product 12, the sum 8. 2 times 6 would work because 2 plus 6 is 8. So c plus 6 and c plus 2. Okay, therefore our lowest common denominator is c plus 6 and c plus 2. And our old numerator 1 will have to be multiplied by the missing bracket. What's missing is c plus 2. We had c plus 6, but we didn't have c plus 2, so multiply numerator by c plus 2. And then we have minus negative 4, so these two negatives make positive 4. Okay, let's combine like terms. So we have c plus 2 plus 4, we have c plus 6. And in the denominator we have c plus 6 times c plus 2. So c plus 6 can be reduced. We end up with 1 over c plus 2. Finally, we have three fractions to combine. Again, we need to look for common denominator. Notice that x squared minus 1 is composed of x minus 1 and x plus 1. So that will be our LCD. Let's change all fractions into the new denominator x minus 1 and x plus 1. Meaning our first numerator 2x will have to be multiplied by the missing factor. So we had x minus 1, we need to multiply by x plus 1. Then we have plus 3x, next fraction. And how does this fraction change? The missing bracket is x minus 1, so we multiply 3x times x minus 1. And finally, we have a minus here. So remember, keep a bracket around the numerator because of this minus. So we have negative x plus 3. And this x plus 3 would have to be multiplied by the missing bracket. But there is no missing bracket. The denominator is exactly the same for the third fraction. So there's no need to change anything in the numerator. Okay, the next step is already easy. We just need to release all brackets, watch the negative sign here, and combine like terms. So 2x times x is 2x squared, plus 2x times 1 is 2x, plus 3x times x is 3x squared, minus 3x. And watch those signs, negative x and negative 3. Everything over x minus 1, x plus 1. So let's combine like terms. We have 5x squared. Then it's 2x minus 3x, so it's negative x, and negative x is negative 2x, and negative 3. Everything over x minus 1 and x plus 1. In the last step, we should check if it's possible to reduce anything. So we should actually try to factor the numerator. Let's see if it's possible. Well, we can guess. Some numbers may be 5x and x, that's the only possibility to split 5. And here's 3, so we could write 3 here or 3 there. If we write 3 over here, then the outside product will be 15 and the inside is just 1. The difference is too great. So let's place 3 here and 1 over there. Okay, now this inside product is 3x and that one is 5x, so they should differ by 2. And we want this difference to be negative, so let's place negative by 1. So this outside product will be negative 5x, and the inner product with the positive sign here would become 3x. So negative 5x plus 3x is negative 2x, so yes, this factorization would work. Everything over, and we have x minus 1 and x plus 1. As you observed, we could reduce x minus 1 with this x minus 1, and the overall answer is a lot shorter, 5x plus 3 over x plus 1. So yes, it's done. Make sure you practice some more questions from the textbook.